In this example, we're going to graph a quadratic function given to us in factored form by hand. And this time we have an a value that's not 1. It's going to be -1 here. So first thing we're going to do is we're going to figure out our zeros. So we know that the general form is y equals a times x minus p multiplied by x minus q. All right, so in this example, our a value is -1. Our p value, x minus p, so x minus 1, it means p is +1. And then we have this x plus 3, that means it's really x minus -3 for q. So q is -3. All right, that means our x-intercepts are at 1, 0. And -3, 0. 1, 2, 3. There we go. All right. So we know the parabola goes through those 2 points, and we know those 2 points are symmetrical. So we can use that idea to figure out the axis of symmetry. So I can either work my way in to the middle by going on the left one and go in right one to the right, on the one on the right go one in to the left, and do that one more time, and we meet in the middle at x equals -1. Or mathematically here, we can just find the average of those zeros. So the axis of symmetry is simply x equals, we're going to say 1 plus -3, and we divide that by 2, and you find the average of 2 numbers. So 1 plus -3 is going to be -2. -2 divided by 2 is -1. So we get x equals -1. So that is going to be my axis of symmetry, if you will. Let's draw it in here. Use a dashed line. There you go. So that's our axis of symmetry. So now we know the vertex is on the axis of symmetry. So what we're going to do is we're going to substitute x equals -1 into the equation. So, and we're going to solve for y. That's going to give us the vertex. So y equals -1 multiplied by -1 minus 1 multiplied by -1 plus 3. Order of operations, let's simplify inside the parentheses. Y equals -1 multiplied by -2 multiplied by +2. All right, so then what do we get for y? Y is going to give us, let's see, -1 times -2 is +2. 2 times 2 is 4. So y is 4. So then what's our vertex? It's -1, 4. So let's plot that point. -1, 4, right there. Okay, so you can see our parabola right now. We kind of have a rough sketch, if you will. We know the vertex, and we know it opens down. It's going to go through those 2 blue points, which are the x-intercepts. But I want a little bit more precision. So now we need to find another value for a point on the parabola. So let's go wider than our x-intercept. So we have 1 and we have -3. So that means I can either substitute in 2 for x, or I can substitute in -4. Well, let's use the easier number. Let's go with 2. All right, so if we're going to use 2, I'm going to get y. Let's change colors here. Change colors. We're going to get y equals -1. I'm going to do this in my head now, okay? We're going to plug in 2 for x. 2 minus 1, 2 minus 1 is 1. All right? And we're going to multiply by 2 plus 3. 2 plus 3 is 5. All right. So then -1 times 1 is -1. -1 times 5 is -5. So we're going to get y equals -5. When is it equal to -5? When x is 2. So we know this point now, 2, -5. So I go 2, -5, bam. There's the point. How far away is that from my axis of symmetry? It's 3 units to the right. So let's find the symmetrical buddy. Symmetrical buddy is going to be 3 units to the left. 1, 2, 3. It's this point right here, which is -4, -5. All right. If I wanted to find another point, I would probably plug in x is 3. I should use the formal vocabulary. Substitute x equals 3 into the equation and find that point. I'm guessing it may be off my graph, so I'm not going to do that in this example. So all you do now is you would take your writing instrument and try your best to kind of draw a smooth curve. Oops, kind of messed up a little bit there. That's okay. It's not perfect science when you do it by hand. All right, and there's your parabola.